Hi friends, in today's power electronics concept session, I will explain to you the difference between an uncontrolled or conventional rectifier and a controlled rectifier. Before we get into the nitty-gritty, let's understand the learning objectives of this session. Please understand that this session is not about explaining the working of conventional rectifier and controlled rectifier. It is only to emphasize the major difference between the two rectifiers. So let's get right into it. The best way to understand the difference between conventional rectifier and a controlled rectifier is by comparing their output waveforms. We shall first look at the conventional rectifier driving a resistive load as shown on your screen. The figure shows the input-output voltage waveforms of a conventional rectifier. The input to the rectifier is AC voltage, which may be derived from the AC mains supply. The rectifier converts this AC to pulsating DC, which is the rectification operation. In other words, the output voltage is a pulsating DC. Let us try to understand the terms pulsating DC. The term DC tells us that the voltage is unidirectional, either only positive or only negative. In our case, we have considered the output voltage to be only positive. The term pulsating refers to the fact that the output voltage is varying continuously. Hence, we can say that pulsating DC means the output voltage is unidirectional and varying continuously with time. One important observation can be made from the output waveform. Current flows over the entire 180 degrees cycle, and the duration of current flow in each cycle is fixed. There is no control over the duration of conduction in each cycle. Let's take a closer look at the input-output waveforms of a conventional rectifier. As you can see on your screen right now, the duration of conduction in each cycle is fixed at 180 degrees. That is, current flows for the entire duration in each cycle of the output signal. There is absolutely no control over the duration of current flow in each cycle of the output signal. Let us now look at the controlled rectifier with resistive load for the same input signal. The output voltage here too is a pulsating DC, but there is one important difference. The duration of conduction in each half cycle is controllable. Let me reiterate, the duration of conduction in each half cycle is controllable. To drive home this point, we consider two cases of the output waveform as shown in the figure. Let us consider figure A. Here, the conduction angle in each cycle is higher. If you look at figure B, here the conduction angle in each cycle is comparatively lower. You will see in these two waveforms there is a duration when the output does not conduct, due to the fact that we can control the duration of conduction of the pulsating DC output. The circuit is called as a controlled rectifier. The duration of conduction can be varied from 0 degree, which is no conduction, which is essentially the off state, to 180 degrees, which is the maximum conduction state and corresponds to the conventional rectifier operation. Let us take a closer look at the input-output waveforms of a controlled rectifier. As shown on your screens right now, in this case, the duration of conduction is 150 degrees. For the initial part of the cycle, 30 degrees, there is no current flowing in the output. For the remaining part of the cycle, which is 150 degrees, there is a current flow, and this is repeated in every cycle. Let's take another case. In this case, you will observe that the duration of conduction in each cycle is only for 30 degrees. For the initial 150 degree part of the cycle, there is no current flow in the output circuit, and current flows only for the latter 30 degrees in each cycle, and this is repeated in every cycle. Thus, we can see that the control of conduction in each cycle is possible with a controlled rectifier. Due to the fact that we can control the duration of conduction in each cycle of the pulsating DC output, the circuit is referred to as controlled rectifier circuit. Summarizing, we may say that number one, the normal rectifier does not control the duration of conduction in each cycle of the output waveform, whereas controlled rectifier provides more flexibility in that it controls duration of conduction in each cycle of the output waveform. This feature makes controlled rectifier circuits indispensable in power control applications. That's it for this session, folks. Thank you.